Just got to give it a moment. There we go. Can you hear me fine? Thanks, Stevie. Thanks, Ned. That species I named after my wife, I did have to ask her first if she wanted to have a carrion beetle named after her. And her reply was, well, at least it's not a dung beetle. But she was quite honored, and as anybody would. Now she wants to go to Nepal to see her species. Okay, I think we're set. So I'm going to tell you briefly what I'm doing in Alaska and with the museum, then get directly into arthropod work in the Aleutians, talk about, and I really think you can't appreciate the arthropods of the Aleutians without knowing the really obvious things that are missing. And there's a nice display over there with a lot of common insects from interior Alaska that are a lot of these are missing from the Aleutians. Then I'll show you some of the typical Aleutian arthropods, what I look for when I'm there, and then we'll get into the meat of the talk. So the first four things we'll get through very quickly. First, I want to acknowledge the U.S. Fish and Wildlife Service who instigated this. It was Jeff Williams and Vernon Bird who asked me if I was interested in investigating the arthropod fauna of these islands, since they knew a lot about the mammals and plants and birds, but the insects were virtually unknown. USGS was instrumental in getting money for the post-eruption work, and National Science Foundation supplied a large grant to the museum, which I'll show you some of that, and that provided infrastructure allowing us to do this kind of work. Many entomologists at the bottom, I list them later in the talk. No entomologist can know all of the species that you encounter in the field, so you rely on a lot of help from friends and colleagues to help out with the identifications and such. So Alaska. When I first got here, the bears, the large mammals, of course, when people go out, it's very exciting to see these things, but the real diversity, the real excitement for me, and probably for most rational people, I would think, is this incredible, almost alien-like diversity of animals that you don't need to go to the tropics to find astonishing examples of amazing evolutionary products, some of which are quite dangerous, yellow jackets. Some are new to the state, like the Compton tortoiseshell in the lower right. Others overwinter as adults. You may see that large black beetle in the top as in your wood pile if you bring wood in the middle of winter, because that's sometimes under the bark. Lots of interesting things. These are all photographs taken in my backyard, some of which were new records for the state. And the reason there's this incredible diversity is this planet. This is a graph showing the number of species of animals in these different groups. This planet is basically an arthropod planet. Most of the species are arthropods, and the animals, the vertebrates that have their skeleton on the inside of their body, which is a really strange place for an animal to have its skeleton, they fall out in this little section over here. Most animals either don't have skeletons or they keep them on the outside, which is, much more logical. In the museum, we're doing a great deal of computerization. Every specimen gets a barcode and has a database record, and this is an example of our new system. Some of the behind-the-scenes shots of the collection, and the NSF grant provided us these new cabinets to store the specimens in. We have a lot in alcohol as well. These are all barcoded and databased as well. This is our spider collection, a brief example of that. The growth in the collection has been almost like climate change. We have this sort of exponential-like rise of catalog specimens, and it's still a fairly small collection as far as insect collections go. We're nearing that 100,000 mark, but a medium-sized insect collection usually has millions of specimens. So we've got a long way to go. It's a very young collection, as you can see. We started in 2000, whereas most collections date back sometimes centuries. Now, what I just showed you were specimens in the collection. So these are specimens. This is species in Alaska. So this graph on the y-axis, you see up to what we think is about 8,000 species is a good round number for terrestrial arthropods of Alaska. This is just the number of names that we've slowly accumulated, pulling them out of the literature, pulling them out of other collections. All together, we're just about 7,500 species documented for the state. In the museum, we have barely 2,000 species represented by our 90,000 specimens. Now, mammals in Alaska, there's about 82 species of mammals in Alaska. So having 8,000 arthropods is quite a large problem for someone to deal with, and getting our collection up to that representation will take decades and lots of work. But so far, we've accumulated 870 species that have been unreported from the state, including, oddly enough, the bedbug is not listed as an official species for Alaska, even though it's here. 536 species that are found only in Alaska. So these are potential endemics. They may occur in Russia, they may occur in Canada, but there hasn't been enough work to demonstrate that. And then 23 species that are new to science, 2 of which I found on Kasatochi. So the arthropods and the Aleutians, I found 28 publications, and there's certainly a lot more, but pulling records out of publications is slow work because sometimes they're quite hidden in the literature. But dating back to 1894, there was a catalog of beetles in Alaska that had some records from the Aleutians, and going through up to 2008, where there was a nice study on flies on Attu. Altogether, 371 species. We've increased that number slightly. I estimate it'll probably double, possibly triple before we're done working there. An example of one of these papers to give you a sense of how you can read a lot of literature and find very few records. This is a beautiful study. They were looking at islands in the Aleutians that had foxes and islands that didn't have foxes, because the effect of the fox on the entire ecology can be pretty profound. The foxes drive away the seabirds or drive them to the edge of the island, and then the seabirds are not fertilizing the inside of the island with guano derived from ocean nutrients. So what ends up happening is you get a different plant community, you get different insect communities as a result. Big impact from these foxes. But in this paper, they listed a species of fly. It's right here, Scathophagium pudicum. It's the only fly species listed in this paper. And I thought this was an odd thing, so I immediately checked the database, check our collections, and I can't find that name anywhere. So I'm curious. So of course what I do is I Google the name. And you want to put your name in quotes when you do this to make sure you're hitting exact matches. And unfortunately, only 6 results, and they all go back to that very same paper. And if you think about that for a moment, that means that name in that form doesn't exist anywhere on the web that Google has searched. So this was troubling. It turned out to be a bit of a problem. I did a bit of detective work talking to the authors. They didn't know where the name came from. Apparently they had gotten it from an identification, but the specimens had disappeared. It basically became a dead end. We could not get either verification from specimens or from the people who had done the identifications because they weren't listed. So this speaks to the importance of museums and the importance of vouchering your specimens when you're doing work like this so that people can go back and determine what that species really was. In this case, the name is a species that occurs in Greenland in the Old World. It doesn't occur in the Aleutians. And it's actually a synonym, a name that's no longer used. So it's a very mysterious name. But that gives you a sense of the kind of problems you run into when you're digging names out of the literature. So the Aleutians are always sunny, bright, warm weather like this. Gorgeous thing. This is the Tekla. I kid, of course. If you haven't been there, it's actually usually very cloudy and cool. This is Adak. Leaving Adak. It's a treeless environment. There's some small willows and a few other imported trees in some of the bigger islands, but it's virtually treeless. The wood that occurs in the Aleutians is all driftwood. That's Great Sitkin. and some other shots. You can see the snow-covered slopes and the beautiful, verdant, just wonderful place to be when the sun is out for sure. Amatignac, and this is a more typical Aleutian day. You have a very low cloud cover. You can't see very far. It's moist. Working in this environment was something I was completely, unfamiliar with. I've barely spent any time in the Arctic tundra, but this is maritime tundra. And so I really was attracted to this coastal habitat. All of this rock material and all of the decomposition and really rich nutrients that are happening right there on the interface between land and water. One of the problems is getting deeply into the interior not only takes a lot of time, and when I'd get dropped off on these islands, sometimes I would only have an hour or two before I'd have to get back on the boat. So rather than spend my time hiking up to the highest peak, I'd spend my time very close to the shore to maximize my productivity. This is the Tekla, the Fish and Wildlife research vessel that runs all throughout the Aleutians during the summers, various research projects helping out. I was fortunate to occasionally have somebody on the boat who did entomology. Usually I was around bird people or some plant people who were more typical biologists in the area. Just give you a sense of how we do the work. We get in this little dinghy, go to shore. As I mentioned, to understand the Aleutians, you really have to know what's missing, kind of the big ones that you might expect. This mosquito, this is one I photographed at Creamer's Field, feeding on my left hand, and I had the camera in my right hand. And this is the last photograph I'm ever going to take of a mosquito drinking my blood, because I'm happy with this picture. There were lots and lots of pictures I was not happy with, but thankfully there's virtually no mosquitoes in the Aleutians. If you're close to the mainland, if you're close to the peninsula, there are some, but I've hardly seen any out in the far islands there. The tubanids, the horseflies and deerflies are not there, these big blood feeders. That was a female taken right on campus here. This is the birch shield bug or stink bug. This is a common interior forest associate and doesn't occur in the Aleutians. A lot of things associated with wood are missing from the Aleutians unless they can feed on driftwood. This is an overwintering queen yellow jacket that's emerged right after that enormous outbreak in 2006. This was the spring of 2007. This was in my yard. And there's no yellow jackets in the Aleutians. Dragonflies, another group that is so conspicuous and so obvious to people, is missing. So a lot of these big obvious groups are just not there. Now why they're missing is probably different in every case. Dragonfly nymphs breed in standing water, and there's not a lot of standing water in those islands. Some of them have big interior ponds, but not all. And but I think it may have more to do with the wind issue. A lot of insects get blown off the islands, and we do find a lot of insects are wingless. It's quite advantageous to be wingless. You have wings, you get blown off, and you do not survive. So there's quite a few wingless things. I'll show you. The Compton tortoiseshell, this is just an example of a butterfly. We have, there's virtually no butterflies out there. There are some moths, but not the butterflies. Grasshoppers, don't know why they're missing, because you'd think they would survive there, but they're not. Haven't found them yet anyway. If anybody knows of any true examples, have been out there, spent some time in the Aleutians, you've seen grasshoppers out there, please talk to me afterwards, or during the question and answer period. Everyone's favorite insect in Fairbanks, the pine sawyer or the spruce sawyer, which some people call the pincher bug because it supposedly has a nasty bite, but I've tried to get it to bite me, and it's not that bad. I think it's kind of a cute animal, and they make a nice little noise if you pick them up, and they'll try to scare you off by stridulating, which usually doesn't scare people off, but probably scares away birds. So those are things that are missing. And the reason this is missing, by the way, is because they feed in dead and dying spruce trees, which are not out there. So what are typically out there? Well, if you're looking along the seashore, looking in these cracks, these crevices in the rocks, which is a favorite place I like to examine because there's some beetles I'll show you later that you can find in these little cracks, particularly on rocks that have guano feeding lichen on there. Looking in the driftwood, and sometimes some fresh water on these islands, some streams, some ponds, lots of rotting. I work in carrion beetles, so it's not just dead animals, but it's rotting plant matter, rotting kelp, all kinds of decomposers, which I'll point out during the Kasatochi work, are very important part of these food webs. A rotting animal that I found no insects on, despite spending a lot of time around it, was that was a shame, really. But those are rich resources. And as I mentioned, this kind of diversity right near the splash zone, right underneath all this rotting kelp, these driftwood here, I could spend an hour in this area. As Ned was pointing out, the birders, they walk off for an hour, go see something, whereas I'm still working this area because the number of species that can be found there is really quite large. Some of these species, this is Scathophaga. I was just pointing out a fly in that same genus. It's a predaceous fly that's associated with kelp. There are centipedes, and at least 2 different kinds of centipedes. Centipedes have venom, but they are not dangerous to people, the ones we have here anyway. This is a beautiful metallic colored, sometimes green, sometimes purple, or a little of both. Very common beetle. This beetle, Nebria metallica, is found all throughout North America, or at least the boreal forest regions. This is an even more common beetle. If you ever find this ground beetle, you'll know it immediately because of these little marks, these 6 little divots in its wing covers. And this is almost a weed, and it's found on all the Aleutian Islands. Less common, but really exciting for me, is finding Pseudo Scorpions. They're arachnids, like scorpions. They don't have a tail. This is a mother, and she's got her eggs behind her there. She's protecting her eggs. They do have venom in their claws. They're predators. They make little silk bags that they protect themselves in from water. And this is a coastal species. We do have an inland species as well. So you turn over a piece of driftwood, and what do you find? Well, it's like the Serengeti under there. This is, all these little purple things are springtails, which are a very common type of primitive insect. And these long black guys are beetles that are feeding on the springtails. And there's some little mites. There's some mites walking around as well. They're predatory mites that are feeding on springtails. So it's a predator-prey interactions. It's all happening within a few square inches. And you can just spend a lot of time studying this. Another wingless thing, of course, this is a daddy longlegs or a harvestman. It's related to the spiders, but it's not a spider. It's an arachnid. And there's a couple species found in the Aleutians as well. Now, can you see the insect here? This is got excellent camouflage, blending in very nicely with the sand. This is a species that was actually named during the Harriman expedition. It's a jumping bristletail. Here's a better picture of it. You can see it standing out on the rock there. They're wingless. They're primitive. They're like living fossils. They're close relatives to firebrats and silverfish, if you've ever seen those living in houses, which are also like living fossils. These insects evolved before wings, so their lineage goes back 350 to 400 million years on land, and they're hardly changed in the meantime. There's another shot of it. So this habitat here, this is a place in these little cracks. There's a lot of things living. I'm going to zoom in. You're going to see some beetles there, and there. These are beetles I'm very interested in. This is the genus Aegialides. They're wingless, and they seem to evolve very quickly. This is a male riding on the back of a female. Here's a better shot of one. This wingless beetle, they are only found in these splash zone areas, rocky areas where there's some kind of guano-feeding lichen, and they're the larvae of one of these beetles. The reason I'm really interested in them is when they were last studied by a German in 2004, he found that every place that they occurred had its own endemic species. Species was known from more than one place, which seems a little hard to believe. And none of the Aleutian Islands had any described species. And I was finding them on every island I went. So there's probably a lot of undescribed species in this group, but the real question is this work valid? Are there really this many species in the group? That's a question that hopefully I'll be solving in the next few years. Each of the Pribilofts has its own species, its own endemic species. So, those are some of the things I look for when I go there. When this eruption happened in 2008, USGS and a number of people, U.S. Fish and Wildlife, we formed a team. These are the various sort of fields of study that came together, and rather quickly we were able to produce an issue of Arctic, Antarctic, and Alpine research dedicated to this eruption. This is the team in the wheelhouse of the tech law. I won't go through all these people, but there's Jeff Williams, fish and wildlife biologist, who was really instrumental in the process. I mentioned a lot of entomologists were involved as well. These are their names, some of which are my students, some are people in town. Other people are Canadian, European, all over the world. We need to send specimens to get confirmation on the identifications. So Kasatochi is about midway out on the chain of the Aleutians. This is Adak here. There's Kasatochi. This is Atka, and Great Sitkin is very close. It's a volcanic chain, as you're probably familiar with. This is a nice map showing the various volcanoes, and there's Kasatochi again. You can see Adak here, Great Sitkin, Atka. So Kasatochi is a little isolated, but not too far from these. It's not like Baldir way out in the middle of nowhere. So there are some other islands that could provide source propagules of insects and plants post-eruption. So there wasn't a lot known about this volcano other than the basics: its height, its diameter. It had a water-filled caldera that was thought to be brackish, a mixture of rainwater and salt water, but it's a very steep and dangerous process to get down to that water, and I don't think anyone's done it. Dense vegetation. We knew a lot about the bird and mammals on the island. So this is one of the biggest least encrusted auklet colonies in the Aleutians, almost 250,000 birds. 1,000 stellar sea lions were living on the north of the island, which is in this map right about here. That's where the sea lions were. But we knew virtually nothing about the insects. So here's the sea lions. And this is actually a post-eruption shot, by the way. So they seem to have done well. Post-eruption. The auklets, however, did not do well. They were mostly off the island during the eruption, but all of their nesting sites were buried in ash and mud, so they really couldn't breed very well. There were actually examples of them making nests in the ash and their eggs rolling down into the ocean. Our subtitle man, Steve Jewett, found auklet eggs underwater after the eruption. It's since getting better. 2010, there are auklets, there are cavities and little crevices for them to nest in. By sheer good fortune, on June 11th, 2008, this was 2 months before the eruption, I was dropped off on the island for almost 11 hours. I mentioned earlier, most islands I'm on, I'm 1 hours to 3 hours. You know, I don't get a lot of time. You got to work really fast. But here, I had the luxury of having more than my usual amount of time, and I worked my way from the beach up to the rim of the caldera, collecting as I went, GPSing each of 9 different sites. So I had latitude, longitudes for all these points. And I'm rather proud of myself, I have to admit, having done that, because a lot of entomologists and even myself 10 years ago wouldn't have done that. I would have just put all those insects in one bag and given it one GPS reading. But now we're getting to be, with Google Earth and with the ubiquity of GPS technology, we're getting more and more precise with our data. And you never know when you're collecting, if the place that you're collecting is going to be destroyed by a volcano 2 months later, and you kind of hope that you've done a good job in case it has. So 396 specimens, which isn't a whole lot, but these are some shots of the island before the eruption. And here's an old fox trapper's cabin that Fish and Wildlife biologists were using to study the auklet colony. Here's a nice shot showing that cabin right there. And this is that same beach I just showed. This is habitat where I was finding a lot of interesting beetles, wingless beetles and such. But once you get away from the beach, the landscape is fairly homogeneous. There's certainly a good deal of plants, however, most of them weren't blooming. This was in June, kind of early June, and a lot of the insects associated with mature plants and with flowering plants were simply unavailable for me to collect. Tourists had visited the island a month later, July 19th, 2008, before the eruption, and had just wandered around hiking and taking pictures, and this is one of them. This picture shows the vegetation that I didn't have access to, all these blooms of lupin and cow parsnip and other large plants. When I got to the caldera, I actually almost didn't go up to the caldera because I didn't think there was going to be any good insect collecting up there. But I figured I had to see it, and I was surprised. There were some spiders that had set up shop right along the rim, making a living on insects that get blown up the hillsides. But this was just a stunning sight. I think Jeff said, if this had been close to a highway, they probably would have made it into a national park or something from its beauty. But it's so remote. And it was a little scary, to be honest. I mean, sometimes entomologists get a bit distracted. You see a pretty moth or something, and you go running off after it. And a few people have had trouble as a result. And so there were some landslides as I was up there, some rock fall, and I was a tad nervous being alone on the island. So it was just a beautiful, beautiful caldera. Various shots. This is one of the beetles I found on the island. This is a wingless carrion beetle. And it's kind of strange. If you're a carrion beetle, you're dependent on your sense of smell to find your food. But this thing has no wings, so it crawls from place to place looking for carrion. It's endemic to the Aleutians. This is a ground beetle. It's a predator, specializes usually on snails. Mouth parts are adapted for pulling snails out of their shells. And this is a widespread species. This is a weevil associated with roots and travels around on driftwood and such, also found on Kasatochi before the eruption. This larva, which is fairly large, I don't have a scale here, but that's a couple inches long. This is a caterpillar, a subterranean caterpillar of a ghost moth, and it turned out to be a species that was unrecorded from Alaska. The little salpingid beetle that I was so interested in, Aegialides, was on the island before the eruption, and this turned out to be an undescribed species, new to science. A second undescribed species from sweeping the vegetation. Unfortunately, I didn't get very many flower-associated insects, but this is the first one. This has actually been described already. I should have updated my PowerPoint because it's no longer in press. It was described in 2010 as a new species of sawfly. Turned out to be a genus that doesn't occur in Western North America. It's got Asian affinities. A very common spider. So spiders get around these islands by ballooning as immatures. They put up some silk and they fly in the wind, and they can travel hundreds, if not thousands of kilometers this way. And so there's some species like this one that you find on every island. So altogether, 396 specimens. I figured this represented about 58 species. They weren't all identified, 2 species. 2 of them were new to science, and 2 were new to Alaska checklist. And then that ratio is pretty good. There's not a lot of places you can go and collect about 400 specimens of something and have 2 of them be new species and 2 be new to the state. Altogether, I figured there was over 100 species. My sample was far from complete before the eruption. To really have a complete sample, you would have to spend weeks, if not months, throughout the season to have a really thorough sampling. So the eruption itself. No confirmed historical eruptions, but it may have erupted before in as late as the late 1800s, but there really weren't good records. 2008, August 7th, it erupted. The earthquake was 5.8 magnitude, but there were over 500 earthquakes of magnitude greater than 2. And the 2 biologists who were on the island were getting a little nervous when those 500 different earthquakes were happening. They were, I mean, to put it mildly, they were quite unhappy, and they managed to get off the island within an hour or 2 of the eruption. The fisherman was able to pick them up really just in time. 3 distinct explosions within 8 hours. A lot of water came out from that caldera, but they estimated that the pyroclastic flow was 800 degrees Celsius. So this was, when we heard that estimate, the volcanologist's estimate, we immediately began thinking this island has been sterilized. The ash cloud went up to 15,000 meters, 14 hours, greater than 14 hours of continuous ash emission. The deposits of ash were up to 30 meters deep, but it's variable. There were regions that were not very deep, less than a meter. And there were cliff faces that protected some regions from being thoroughly buried. So it turned out that it's not just continuous burial or even burial. The island increased in size by 40%. So the ash enlarged the island by a considerable amount. That crater lake in the middle increased as well. Now, unfortunately, we don't actually have a photograph of the island erupting. This is from Hebert Island, Mount Cleveland eruption the same year, just as a illustration. The ash cloud drifted from Kasatochi all the way to Adak. The sulfur dioxide was one of the largest emissions of sulfur dioxide, and this is a NASA image of that cloud moving towards the southeast. This photo was taken on 23rd of August, so a few weeks after the eruption, but it's still lots of smoke, and the first shots post-eruption. That cabin was completely buried. This cliff face was filled in. And you can see some of this area here. This was blown out, which used to be a nice wall. The Alaska Volcano Observatory and Fish and Wildlife scientists, they visited the island a few weeks after and reported back that all of the island is covered with layers of ash and pyroclastic flow material. Most, if not all, bird and mammal breeding habitat was covered. Intertidal and nearshore subtidal communities were overrun by hot, fast-moving pyroclastic flows and subsequently covered by ash and sand. So we wanted to document the impacts of the eruption, establish a baseline from which long-term comparisons could be made, and this collaborative effort from all these different groups. In that issue devoted to Kasatochi eruption, we invited Roger Del Moral, who turns out to be, I didn't know previously, but a world-famous ecologist who specializes on not just volcanic eruption ecology, but ecosystem assembly work. So he knows the literature very, very well, and wrote a final article in this journal and pointed out that this provides an unparalleled opportunity to clarify the understanding of ecosystem reassembly. And why did he write that? Well, it turns out that of these major eruptive events, Kasatochi, Surtsey in Iceland, Krakatau you may have heard of in Indonesia, some less popular or well-known eruptions in Japan and Russia, and then Mount St. Helens in the US, the only one that actually had prior data, pre-eruption data, is Kasatochi. We had not just the insect data, but plant data, bird data, a lot of different data sets pre-eruption, whereas all of these others didn't. Now, Surtsey, of course, you couldn't have, because Surtsey erupted from the ocean. It wasn't an island before eruption. But still, it's a fascinating example of successional ecology and ecosystem reassembly. We get to compare how the island returns, or how closely it returns to its pre-eruptive state. This is a before and after shot, obviously. I really like this paper by this article. Glenn Bernsilver wrote this title, "Only the Strong Survive." It's rare for insects to get such a manly kind of title. But this was a nice coverage. There's been a lot of media attention, as you've probably heard. This is the pre and post-eruption outline. So we have in yellow pre-eruption. You can see some outcrops that really haven't changed the shape of the island much. The currents in the ocean have swept away the ash here, and these outcrops remain almost in their pre-eruptive state, whereas other parts of the island have changed dramatically. So when I heard about this, I actually wasn't that excited, to be honest. I thought that first off it would be lots of mud and there would be no living things, and that would be true for many years. And I didn't really relish the idea of spending a lot of time where there was no insects. Maybe some of you might not understand, but I like to be around insects. So we figured colonizers would come from air, from ocean, from vertebrate transport. Sometimes birds bring in nesting material that has insects in it. And few examples, this would be very rare, it would be a very slow process, and most of these introductions would fail. We know this from other systems like Mount St. Helens, where the majority of insects that landed on the ash plain die and become food for just the few that can scavenge and live off those aerial fallout. Surtsey, the one I just mentioned in Iceland, it erupted from the ocean in 1964. By 1975, there were only 3 arthropods considered to be truly colonized on that island. So that's a long time span to get very few organisms established. So as I said, we're going to document, describe, analyze pre-post eruption. One thing I really wanted to do was test this heterotrophs first hypothesis. And this is based on the work in some of these more famous systems, Krakatau, Mount St. Helens, but also looking at glacial retreat systems, looking at snow fields, very low productivity systems or sterilized systems. This hypothesis basically states that arthropod scavengers, predators, and parasitoids would be the first stage of ecosystem reassembly. And that flies in the face of most people's intuition, and not just intuition, but also you open any ecology textbook, college level or not, and you're going to see statements like this. Plants provide the starting point for all food webs. Food webs are based on primary producers, i.e. plants. or autotrophs, things that make their own food. So this Hodgkinson review in 2002 laid the groundwork for, I think a wonderful base of study for Kasatochi, for my work anyway. So they're basically saying, it is proposed that as a general rule, primary community assembly by autotrophs, i.e. plants, is preceded by a previously unrecognized heterotrophic phase that may be instrumental in facilitating the establishment of green plants and consolidating the assembly process. I already mentioned in Mount St. Helens there's this aerial fallout. Over 1,000 species of insects were frequently falling out of the sky and landing on this barren plain and dying mostly, and becoming food for a few scavenger species that could live off this aerial fallout. That's a lot of nitrogen, a lot of fertilizer coming out of the sky on this virtually sterile ground. Most people ignore that as an important stage of ecosystem assembly. They basically say, okay, there's all these scavengers and predators and there's food coming out of the sky, but it's not really started until the plants get there. And I beg to differ. One of the things I saw that was rather humorous in this article at the very end in the acknowledgments, to the unnamed plant ecologist who, while measuring aerial inputs of nitrogen and phosphorus into experimental plots, threw dead insects away, regarding them as contamination. So Kasatochi is a great test case to see just how important all these scavengers and predators are as the beginning of a food web in this sterile and new environment. So these are post-eruption photos, obviously. Some of those outcrops that have that kind of pre-eruption status haven't changed too much. This is areas that Ned was talking about being very difficult to walk in. When you have these low plains with lots of mud moving downhill, this is where your boots can come off. But typically, you get up into higher land and it's not too bad. Although it can be extremely slippery if you get even the slightest rain coming down, then it's just a mud fest. But just some of these pictures taken from the boat before we landed. Incredible erosion patterns. I'm no, geologist or volcanologist, so don't ask me about, these layers and all this stuff. That's not my specialty. But there are people who could answer those questions, and I can point you in their direction. The boat occasionally would have trouble with difficult marine conditions. The waves occasionally made it impossible for us to make land, and made it challenging for people to keep their lunch down too. This was, but it really was exciting to get on the island for the first time post-eruption. This is August 2009. These are the botanists, Steve Talbot and Sandy Talbot there. And first thing I do, turn over some driftwood, look underneath, and I see a few. My first evidence of insects mixed among this dirt are some pupal cases of flies. They're empty, but they're there. And this is telling me that indeed we're getting exactly what we expect by marine, by air. Insects and evidence of insects are making it to the island. Guano from birds dropping, so some fertilization. Some of these ravines were pretty deep, these gullies. Jeff Williams at the bottom. This is where the cabin was. There was no evidence of the cabin. They occasionally find pieces of plastic or containers that had been associated with the cabin washing up on the beach, but the cabin is gone. This is just a reminder of the pre-eruption cabin. This is Ned there, Ned Rizzo, walking with Jeff, and this is the photo that Ned took of me that he was talking about when he introduced me. It does, my eyes have begun to go, so I really have to get my face as close as possible to the ground to make sure I'm not missing anything. But unfortunately, I turn over a lot of rocks, look in a lot of places, and find very little. One thing we did to try to replicate the work done on Mount St. Helens is we set up these fallout collectors. Those are golf balls. Very scientific design. Used golf balls. We, got to save money. But the idea here is that they are 1/10 of a square meter each. We embed 10 of these so that we have 1 square meter represented. We're not trying to trap and kill insects. What we're trying to do is catch the amount of dead insect matter that would normally be found on 1 square meter of ground. And that's if you think about that, that's kind of a hard thing to do. Insects die, they get washed away, they disappear. So this gives us they can underneath these golf balls is mesh, mosquito netting. So we can then collect the insects that have accumulated over time. And we ended up with some flies that we could calculate up that if the distribution of flies on the island was evenly distributed or randomly distributed, we would have a very large number of flies dying per day, which I think is a bit unrealistic. But we're trying to improve on this technology. The measurement is not, I think, perfect. We have problems. We have flooding issues, ash getting in. It's really a challenging thing to do, to measure that kind of input. Plus, we'd really like to be able to separate aerial input coming from other islands from input that's being generated by Kasatochi itself. So I was very interested in kelp, as I mentioned. The rotting, this is a lot of organic matter. It's a great food source. It's covered with these kelp flies. This is this predator, Scathophaga. It's really between the kelp and the carcasses, it's the only food on the island, basically, for macroinvertebrates, I suppose. At this point, I hit a rock outcrop, and as I was investigating it, I found something that I was really surprised by. In these circles were about 50 dead flies. They were perfectly intact. There was no obvious sign of what caused their death. And it didn't take me long to begin to get worried, because what probably killed them was gas coming out of the volcano. And if gas is flowing out of the volcano and poisoning the flies, it could hurt us as well. They did find 2 birds that were dead by unknown causes as well. So we had reason to be a little nervous. Here's some of the museum specimens I took back. So this is that one I keep talking about, the Scathophaga predator. Here's another kelp-associated fly. So these were all flies I was finding at the kelp on the beach post-eruption, some in large numbers, some in very small numbers. This one was very abundant, but a very small fly. You can see that's just 2 millimeters there. But they would be under fish carcasses, under kelp. This was I only had 1 or 2 specimens of this thing, but it was also kelp-associated. Only 1 specimen of this is a blowfly, so it feeds on carcasses, and it's a very fast flyer and could have come from another island, and we had no other specimens, so there's no evidence of it breeding. So the survivors had these little pockets. You can see some plants here, probably some grasses underneath that overhang that had survived and come back from their root stock that had not been sterilized. Other plants were coming back as well. So this is a senecio, and this was, if you look on that flower, zooming in, this is the first example post-eruption of an insect-plant interaction that I documented. This is a fly probably getting nectar from that flower. Lupin coming back. Now that was all 2009. 2010, when we returned, we started seeing evidence. What I just showed you were survivors coming back from roots. This is on the beach. These are seedlings that are coming back from being washed ashore. So these are almost certainly immigrants to the post-eruption island. Here's 2010 as well. I think the botanists are calling this the Garden of Eden because it's like the biggest area of plant growth on the island at this point. On the far northeast here, there is a big cliff face, and I spent a lot of time walking along the base of this cliff, right along the edge here, looking in every nook and cranny I could find. And when it rained, this is where you just got to worry about sliding down that slope. It's a pretty steep slope. So behind these nooks and crannies, underneath, I would sometimes find pre-eruption soil. You could tell because it was a completely different color from the ash. And I would find my beetles. So these are the wingless carrion beetles hiding in those rocks. Now, since they're wingless, the chances of them having gotten to the island since the eruption are very, very small. We're currently trying to answer this question using DNA to see if the post-eruption beetles have identical DNA essentially to the pre-eruption from the same island, or whether we can identify markers that would indicate they're from nearby islands. They feed on these birds. So here's an example. One bird had, I think, 60 beetles on it. And some of these beetles are light-colored, which means they've recently molted from pupa. And that means they're actually breeding. The larva, pupa, adult, they're not just feeding, but they're really an actively breeding species on the island. And that's a kind of a rare thing. Now, I alluded to the fact that people don't really think these scavengers are an important part of ecosystem assembly, and it turns out Roger Del Moral is one of these. So he said the arthropods found in 2009 were scavengers, necromass feeders, not herbivores, and the assembly of terrestrial arthropod communities has not truly begun. Basically saying that my paper, which says that we have a shift from a plant-based to a necromass-based food web, is not true. I don't know. I think the necromass-based food web at this point is thriving and very interesting. In fact, there's a lot of systems that depend on necromass. This is DOM, dead organic matter. Going into the decomposer system in a forest, in a grassland, in a plankton community, in a stream community, dead organic matter and the decomposers are a very important part of all ecosystems, some more so than others. The stream community is a good example of what Kasatochi is like. There's not a lot of primary production. It's mostly dead organic matter and decomposers driving the system, and that's the way a lot of streams work. So this is my attempt at making a little bit of a food web. We have a rotting kelp in 2009, and there's some fly species, and then there's a predator feeding on those. So we have two trophic levels. We have a little, maybe a little bit of pollen or nectar going in, but hardly any plants are blooming, and there's hardly any plants there. So this is probably a very, very small component. The bird carcasses were feeding the blowfly, the two carrion flies, and also the wingless carrion beetle. In 2010, a bunch of these species were not recovered. The ecosystem assembly is rather dynamic, lots of change. We had new things coming in. There's a lot of fungus now on these carcasses. And so this is the 2010 food web. We have the carcasses feeding this very common small fly, which feeds the predator. This predator may actually in turn be fed upon or somehow be fed upon by a beetle that I found in 2010 that had to have been there in 2009 and been missed. Bird carcasses are feeding fungi. Driftwood is feeding fungi. We're getting some springtails, some mites. So it's getting more complex in 2010. This is the most exciting thing, I think, in that this is our first example of an autotroph being fed on by an insect. So that's our first sort of non-decomposer, non-predator, true breeding population. So up where I found all those dead flies, there's this splash zone area. These rocks are constantly getting inundated by marine spray, and this algae all over the rock is being fed on by these chironomid midges. These were identified by Steve Peake, local Fairbanks dipterist who works on flies and really likes chironomid midges. So these midges, they're mating. We have males and females. We have a lot of them breeding in this area. I was really excited to find that population. So altogether, the 2009 results included these presumed survivors, a lot of these came out of an old bird nest that Jeff Williams had found, and some of these are clear bird nest associates. Some beetles that are only found in bird nests, ticks, of course, they're parasites of birds. There were some parasitoid wasps and some predators in there as well, but we found these all in such small numbers that it's presumed that these are not actually breeding, that they were survivors that are just barely hanging on. And then we had altogether 17 species. 4 to 9 of them were breeding. So I think it's more on the small side, more like 4, but it's kind of hard to be sure. Comparing 2009 to 2010, we have almost the same number of species, but a big turnover. So 7 of the species that we found in 2009 disappeared, and we had 8 new ones, or 8 that weren't found there. Obviously a huge loss from 2008 to 2009. So the future work, as I mentioned, we're going to be looking at genetic markers to see if we can compare the Kasatochi beetles and flies to nearby islands and hopefully have some idea about immigration versus survivorship. We want to obviously keep our eyes on this fledgling ecosystem. It's going to get more complex and more interesting, and it's just a once in a many lifetime opportunity to witness this firsthand. And then finally, right now we're working on stable isotopes as well to try to get a quantification of how much of the food going into these insect communities is coming from the ocean as opposed to plants. So that's our current focus right now. So I'll leave you with a sunset shot of Attu, which I was able to visit for the first time last summer. And I'll be happy to take any questions. Yes? Don't know. Many years, certainly. I would be surprised if it wouldn't take many decades to really get back, possibly even as long as 50 years. We really don't know. And this is one of the exciting things. I was surprised, though. I mean, one of the things that was very surprising is how little we did know. We expected there to be virtually no life and for it to take a long, long time. But it's already pretty exciting. We already have plants, we already have insects, so it's going faster than we thought.
If you have a question, you can raise your hand and we'll come over with a microphone so that way we can hear it. Anybody else? Any questions? I actually had a question, if you don't mind. I was wondering, when you collect your specimens, do you just take the photos and leave them living, or if they're dead, do you bring them back? I was curious about that.
Yeah, we collect them. We don't collect all of them, but we need them to identify them, and we need their bodies in the museum as evidence. So along those lines, the north part of the island with the sea lion rookery, we're not going there, so that we don't disturb the sea lions, but also so that a portion of the island is remains untouched.
Thank you.
Yep.
Oh, I see some in the back.
The primary food source coming in, it's mostly this kelp and these birds that are dying. There's some fish as well that get washed up on shore, but that's the bulk of the organic matter coming in right now. Yeah.
Because then that might mean that the progress would tend to come from the perimeter and from the ocean and potentially slowly climb the slopes.
Yeah. The plants need to get established before they can move up from the coast. I think this decomposer scavenger-based food web along the coast is probably typical of all the Aleutian Islands. We find the same species everywhere, and these volcanic islands, I wouldn't be surprised if this is a very typical phenomenon.
The stellar sea lion rookery, was that filled with sand and ash too, or was that part that was still with vegetation?
They were out to sea at the time, and there was some ash, but enough of the rain and seawater cleared their rocks off that they're happy there now. Yeah, they're doing okay. And they feed in the ocean. So the intertidal and the benthos has been pretty destroyed. Underwater footage from Steve Jewett's work shows the kelp forests were mostly wiped out. They're beginning to come back. We're seeing more, but lots of the invertebrates and kelp and everything down there were buried in ash.
We have a question back here.
Okay.
Are you or any other scientists planning on going back this year?
Oh, yes. Yeah. We're going back this year. At some point, we're probably going to start skipping years. But I'm guessing maybe we'll go every year for 5 and then start skipping and maybe go every couple years. And it's hard. I would personally find it hard to not go back each year just because I really want to see what's happening and what's changed. It's just a matter of money and timing and other factors. So, good question.
The growing season, is it 2 months, 3 months, 6 months frozen?
I don't know offhand. It is a short summer, though. Really, you don't get much blooms in June. It's mostly July. By August, things are winding down. It's like the interior. So it's pretty short. Yep.
I have a question over here.
I was curious, why did you spend so much time on Kasatochi before the eruption compared to other islands?
Right, yeah, that was just really good luck. It turns out they had planned some bird surveys, and they picked up the 2 biologists on the island, on Kasatochi, and took them on board so they could, shower and bake a cake and stuff like that, and go check out this other bird colony, which they spent almost the whole day checking out before they came back to get me. So it was just really good luck.
Do we have a last question? Okay. Well, will you all join me in thanking Dr. Sikes for giving a lecture tonight?